Hello, and welcome back to Two-Phase Tuesdays. I'm your host, Lucas Beran, and I really appreciate you tuning in today. So this past month and a half at Excelsius has been very busy, really doing lots of heads down work, executing on the orders that we have, preparing for at-scale deployments of two-phase direct-to-chip liquid cooling. In accomplishing that, we've been having lots of meetings with our Series B partners, meetings with our customers, planning with our customers. We've also hit some exciting internal milestones that we're really proud of. And then lastly, we are entering our very busy spring trade show season for the marketing department. So we've been doing a lot of work to prepare for that. Lots of exciting things to show off at the trade shows this year. So we'll be at Data Center World in London this week, March 4th and 5th. And then a few weeks later, we'll be at NVIDIA GTC, March 16th through 19th. So lots of great opportunities to connect with us this month. But we have a great guest today who leads our commissioning team, which is a very critical step in scaling our technology. So without further ado, let's go ahead and bring our guest in and get this show started. So for today's guest, I have Jacob Moore, Principal Engineer here at Excelsius. So Jacob, thank you for joining us on the show today.
Thanks for having me, Lucas.
Absolutely. So I want to start, as I normally do, with your background, because you've got a strong foundation in thermal engineering, one of our 6 PhDs in thermals here at Excelsius. So can you walk us through that path and kind of what pulled you towards heat transfer and fluid systems in that education?
Sure. I would say it started in my undergrad
Okay.
when I was working on a senior design project, competing in the NASA student launch competition.
Wow.
So that was basically a way for undergrad students to be exposed to the NASA design process.
Okay.
You have lots of designs, tests along the way, reports to actual engineers at NASA who are reviewing your documents, your test data, and stuff like that. So it's an exposure to all aspects of leading a project from cradle to grave.
Mm-hmm. Wow, very cool. And so, in a lot of that work, you did a lot of advanced cooling work, but it wasn't actually on phase change systems. So I'm curious kind of what attracted you to explore phase change systems and ended up joining Excelsius.
Well, from my PhD work after undergrad, I studied gas turbine engine film cooling.
Mm-hmm.
So a lot of that sort of study is experimental in nature.
Okay.
There's not really great ways to simulate those things in CFD or analytical models even. And so you always need an actual physical model to run tests on. And I really like the hands-on stuff where you're connecting instruments and sensors to things, taking data, trying to replicate the physics you would see in the real world application. So that sort of hands-on experimental work drew me here, where with boiling and phase change, there aren't great computational models of that always, and there is still a lot of hands-on work that's needed. That's the type of work that attracts me as an engineer.
Okay, so the innovation excited you, opportunities to do, research, kind of pave a way in a new industry that, sure, this phase change technology exists, but to apply it to data centers requires some research quantification of how that process happens to produce the best results, for our system, so to speak.
That's right. Yeah.
Very, very cool. And you've been heavily involved in the development of a lot of our systems with a number of different roles over these past 2 years that you've been here at Excelsius. So can you walk me through some of the roles that you've had, the projects or products that you've worked on, and ultimately what led you to becoming the leader of the commissioning team here at Excelsius?
Sure. I joined on as a thermal engineer designing cold plates for the team.
Okay.
And had a hand in that for a little bit, but went on to lead a project in developing test capabilities internally for us to produce 250 kilowatts of heat within a single IT rack.
Okay.
This was in development of our MR250 CDU system, and we didn't have that capability internally, and there's no off-the-shelf capability to do that in that form factor with the two-phase solution. So I designed a system that simulates the heat load of individual chips in the forms of many 1U servers that then go and connect to our CDU system and has the temperature measurements, power measurements that you need to be sure that you're simulating that heat load at that node level. So this internal tool then gained a little traction with our customers as part of proof of concept deployments of the CDUs, and one thing led to another, and now it's its own product line in the commissioning products, which I'm leading.
Fantastic. And, as I, talk on the show, I've talked a lot about 2025 as kind of the year of momentum, the year of proof of concepts, which involved a lot of those thermal simulations that you've referenced, demonstrating the capabilities of our products. But 2026 is really about the year of scaling for us, where we're deploying these systems in mass, to support real workloads, where commissioning becomes a really important piece of that process. So for our audience, who may not necessarily know what commissioning means to the level of detail that you do, can you kind of break that down in the context of data center cooling and just provide an overview of what is commissioning?
Sure. I mean, I'll start off with kind of a high level non-data center example.
Okay.
If you've ever moved into a new build house or have a friend who's done that, and let's say a light switch didn't work or an outlet didn't work or the sink or faucet works weird, that means that house wasn't commissioned properly in all of its electrical plumbing systems.
Okay.
You can imagine that in kind of a scale of hundreds, thousands in a data center. Think of how much power is being delivered there, how much cooling is needed. All of those systems need to be tested before you're putting your high value compute in there and expecting it to run right away. You need to ensure that it has a good environment to run in.
Okay, fantastic. I'll next time I have to get a new house, I'll make sure I bring you along to do the commissioning walkthrough and make sure everything works as intended.
Yeah, happy to help.
Awesome. So in regards to commissioning, maybe kind of a comparison of single phase versus two phase. Two phase has the perception, I might refer to it as a myth that it's complex. So for the two phase commissioning process, do you see it as more complex than single phase or more critical than single phase? What would you say difference-wise there between single phase?
I mean, sure, there's a difference in the physics within the CDU itself, but from the facility's perspective, each type of CDU, whether it's single phase or two phase, is dumping heat into the facility water loop through a heat exchanger.
Sure.
It's almost agnostic to, what sort of physics are moving that heat from the chip to that heat exchanger. Okay. So it looks very similar to a single phase type of commissioning. And, there's not really much more complexity needed there in that sense. Okay.
Is there, opportunities where maybe when we look forward a little bit more in terms of different technologies that we implement, kind of thinking about the opportunity to do maybe refrigerant to refrigerant, would that introduce complexities, as we look to potential solutions in the future?
Not necessarily complexities. I mean, as you have waterless data centers, which is kind of a hot topic in the two-phase sort of technology space, the commissioning products just evolved to meet that need. Okay. There's not necessarily additional complexities with it, but rather you need products that are sort of designed to handle that sort of fluid heat load, heat transfer situation.
Okay,
compared to a single phase.
Yeah, no, that makes a lot of sense, and I really want to dig into kind of the product evolution of commissioning. But before we get there, I do have a two more quick questions to kind of talk about what you're working on today. But so when we show up on site to do the commissioning work, let's go with what are the top three things that you're validating or potentially tuning, when it comes to this commissioning?
I think number one is probably power. Okay. That's one of the things you hear about data centers.
Yeah, lack of power right now.
Yeah, that's the bottleneck. So we want to make sure that the power that's being delivered locally to the IT space is enough to power your compute.
Right.
And so a commissioning product could take that power, convert it into heat, and then test the second thing, which is your cooling systems.
Right.
That could be air cooling, that could be liquid cooling. You're wanting to make sure that your cold aisles are cold, your hot aisles are hot, your air is flowing where you want it, and you also want to make sure that whatever you're dumping into liquid cooling is working in that sense too. So getting the required flow rate of facility water, getting the required temperature of facility water as you're running full power with your commissioning load bank, what have you.
Right, right.
And then finally, you want to commission the CDUs themselves as well. So these types of load banks, or in our case, our thermal simulation rack,
Right.
are meant to ensure that our pumped CDU system is working as well, working to spec. If you have a certain facility water flow rate or temperature, you want to make sure that you're hitting the benchmarks that we've quantified in our labs, but then replicating that in the field.
Right. Yeah. And, our systems, of course, depend on that facility water loop today to enable the performance that we promise to our customers. And I certainly know there's been instances where we haven't seen the flow rate that we were, expecting on the facility side. And so we'll work with those teams to, try to diagnose what's going on to make sure we can get the necessary flow in our systems to deliver the performance that, we're ultimately selling to our customers, right?
Yeah, I mean, it takes a lot of communication from all sorts of different parties to make sure that you have the right conditions for deploying these state-of-the-art IT systems.
Absolutely. And then, I've noticed as you've been talking, you've touched on a couple of things, working with the folks on the CDU development side of the house, working, on the Vaporator team and with the Vaporator team developing these load simulation sleds. So I'd love to hear a little bit about like what collaboration looks like in your role as the leader of the commissioning team, with other teams here at Excelsius.
Yeah, with commissioning products, especially in our load simulation sled system, we kind of touch on all the other disciplines within the company. I mean, the load sleds themselves operate connected to our CDU systems, like the MR250.
Okay.
We want to make sure that the amount of delta P, the amount of flow that we need to cool the loads within the load sleds is something that the MR250 CDU can provide. Right. So there's communication of those specs there, and working together to harmonize the fluidic connections that they give us versus what we're going to give them in heat. For collaboration with the cold plate team, we use cold plates in the load simulation sleds. So we want to make sure we have high performing cold plates. There's back and forth about packaging, and it gives us a test ground as well to test out our cold plates in high volume before, say, we have a deployment in the field. It gives us a test ground, which is very valuable from an engineering perspective.
Yeah.
And then, finally, I mean, we're delivering tons of power to these racks. So the electrical and systems engineering team gets involved as well with power control, taking into account things like balancing phases, making sure that your facility is happy with you drawing so much power and putting that into thermal load that the CDUs then handle.
Okay. Well, it sounds like you have to know a little bit of everything and probably have to work with everyone fairly extensively to make sure everything lines up to do this commissioning in the proper way.
Yeah, it comes with the territory.
Well, I'm glad we have you on the job there because you're doing a fantastic work there. And as we start to look forward more, and we've already talked about kind of 2026 being that year of scaling. Referenced the Dark NX project a couple of times where we're talking about 300 megawatts of deployed a data center deployed with two-phase direct-to-chip liquid cooling. So as we kind of talk about scaling deployments, for that project as well as globally, how do you see our commissioning evolving and what needs to mature?
I think having a broad offering of commissioning products will be important. I mean, there are different ways of heat rejection in these data center deployments. I mean, we were talking about potential refrigerant to refrigerant architectures, so something that could be well equipped for that. You also might have certain customers who don't need down to the chip level simulation of the heat loads. You might want something more of a gross heat load, maybe a big refrigerant boiler that just is dumping heat en masse into the system. So really we want to meet what our customers need. Right. And it started off with the load simulation sled, which has served us very well internally and our customers so far, but we're not going to stop there.
Okay. So lots of job security ahead for you. It sounds like developing new products to support the commissioning efforts that your team is working on.
Yeah, a lot of exciting new developments.
Awesome. One of the other things I hear about a lot that I kind of wanted to pick your brain on is really digital twins and try to understand digital twins and kind of how they can correlate with commissioning, if they correlate with commissioning. I hear them talked about, in helping, with data center designs and validating those systems to, showcase that everything works. Do digital twins have a role in commissioning, or maybe am I thinking about that wrong?
I think they do have a role. I mean, they won't replace the initial commissioning that's required. You can't really simulate somebody hooking up a breaker wrong.
Okay. Oh, that makes sense.
Yeah, there's a human element to it that
Okay.
that really can't be simulated that well. So that initial push to test out your systems before you deploy anything, you'll always need something for commissioning that.
Okay.
You can't get around that. But once you're up and running, digital twin starts to come in handy. It tells you, I look at my real system performance that I'm measuring inside the data center. I'm looking at it as compared to our analytical model that we've made and validated.
Okay.
And if those start to diverge, maybe that tells you need some maintenance. And you could use commissioning products to sort of assist with that maintenance. You could go and periodically test your systems to full load when you might not necessarily have that available to you with compute, your actual IT load.
Yeah.
So you go in, you periodically push it to its limits, make sure that it's still performing well, and you can use that digital twin to inform how often you're doing that or when you do that if you're going to react to something.
Okay, that makes sense. Obviously with how quickly chip TDPs and heat fluxes are increasing these days, it would probably be a nerve-wracking upgrade to go from, the last generation to the next generation without, testing your infrastructure again to make sure everything aligns, everything still works with the latest and greatest compute out there.
Yeah, you don't want to be banking on somebody being like, I think we sized it to that.
Yeah, I like that. I like that. No, this has been an awesome conversation, Jacob. I appreciate you joining. I've learned a lot. As I normally do, I love to kind of close with seeing if you have any words of wisdom that you can share. Really thinking about students that are graduating and potentially entering the workforce, engineers early in their careers, whether that's in the data center industry, wanting to join the data center industry, wanting to join liquid cooling specifically. Do you have any skills you'd highlight that they should be working on, or just any kind of advice that you'd share for those that are interested?
Yeah, I mean, I'll start off. The data center industry is a great place for engineers. There's pretty much an application for any type of engineer, the electrical, mechanical, thermal within the liquid cooling and IT space. There's sort of process engineering that like a petrochemical engineer might even have some application in the design of the buildings, and even in the individual liquid cooling, like CDUs themselves. So really, I think anybody can get into the game here. And in terms of, what sort of skills, I guess, a young engineer might want to target for this sort of work. I mean, I would say for this and it's really hands-on work, design, build, test. You learn the most from building something, learning how it worked, learning where it didn't work the way you thought it would, and iterating on that. Cut metal, turn wrenches, code up Arduinos, hook up sensors. That's all the best learning as an engineer.
No, I love that. And, I was an industry analyst for 10 years before I joined Excelsius, where I talked about the infrastructure as opposed to touching the infrastructure. And now that I've been at Excelsius for over a year at this point, I've had the opportunity to personally get hands-on, and that resonates with me because it's been such a valuable learnings in my process to get hands-on, to do all the things you're talking about. Not all the things you're talking about, some of the things you're talking about, which have been immensely helpful for my education. So wise words from Jacob, in my opinion. But Jacob, that's all the questions I have for you today. This was a great conversation. I've learned a lot. I anticipate our audience has as well. So I really appreciate you joining the show. And I'll let you get back to it because I know it's going to be a busy year for you.
Absolutely.
In terms of getting some of these systems out there and ensuring that they perform as expected. So Jacob, thanks again for joining. And I'll look forward to getting a progress update from you later this year.
Sounds good. Thanks for having me.
Fantastic. A big thank you to our guest, Jacob, for joining us today. And thank you again for tuning in. Just as a reminder, there will be a couple opportunities to meet the Excelsius team this month at trade shows. First this week, we'll be at Data Center World London on March 4th and 5th at booth F50, displaying our MR250 CDU and components used to enable a server to be compatible with two-phase. And then we'll be at NVIDIA GTC in San Jose, California, March 16th through 19th at booth 129. So hope to see you at one of those shows where you can see our technology, see what we're working on, talk with us about what's in front of us. Very exciting year for Excelsius in 2026. So thanks again for tuning in. We'll look forward to seeing you at the shows or look forward to seeing you the next show we have here. Thanks so much.